All right. This is group 4, lesson 7. This is, we have Christina and Patricia and Spencer. So I was just telling Spencer that I did not quite get through the preparations yet. I had another class and lots of stuff to do at work, and so anyway, it's my excuse, but yeah. So I'm going to do that after I get off of here tonight. But I read it all, and I'm starting to go through the videos just to help me understand it better.
I know what's the first one.
It looked like it was pretty simple. Like they're, instead of giving us the deviation, they're showing us how to come up with the deviation with the formula, is what it looked like. So
correct. Yep.
If you want, we can go ahead and start the quiz and see how we do.
Okay.
And then let's see, I need another screen here. Course math.
Looks like there's 15 questions. Not too bad.
Okay. All right. Group meeting quiz. Start. Okay. A1, 2. Oh, you guys want to see my screen, huh? You don't want to look at me.
I'm good either way because I've got the up on
mine. That's the one. Shit. Okay.
Close on Windows. I have too many.
I know. That's me. I get them all over the place. I hate that.
Yeah. Okay. Okay, I'm ready.
And calculating, I think around to 3 decimal places. Here's my paper here. Okay, if the normal probability applet, use the normal probability to find the combined area under the standard normal curve that is to the right of Z.
To the left.
1.3. Copy that number. 1.358.
Okay.
I think that was the Z score or the area. Sorry. It's a Z score.
This, yes.
58.
0.1745.
Left of the Z score and right. So both left and right. So 0.1745. Oh, round it, huh?
1.75. 0.175.
175. Yes.
What I got? Yes.
So it's
0.175. Okay. Of the following will have a smaller standard deviation if 9 observances are randomly drawn.
which of the following will have a smaller.
I'm thinking it's the second one, but I'm not positive.
You think it's a sample mean?
Yep. I can't remember though.
Smaller standard deviations. If 9 observations are randomly drawn from a population.
I don't know. I think we need more information, right?
No, I think it's on the concept. I'm trying to where it's at of how it's a concept question.
Is it?
Yeah, so it's just but I'm trying which one it is.
Yeah, but it's 9 observations out of 9 observations from a population. More standard deviation. I have no idea, honestly. Let's see.
Smaller standard deviation, 9 observations. So standard deviation. To find the standard deviation, you divide the
Sample size.
9
No.
observations. So observations would be the square root. I think it's the sample mean too.
So for some reason, that's the only one that's clear. I can't find it.
Distribution of individual observations X.
Where I saw that, like I'm trying to figure out where I was looking, but
Well, the first one,
It's
that's
is
my
that the
sample
number?
mean.
Well, yeah. The problem is it's the sample mean is said like 22 times in this week's text.
Yeah.
Distribution. Let's try that distribution.
the randomly drawn. Yeah. It's the second one. I think it's just randomly drawn from the population is the process of it.
Where is that? You said where it says randomly drawn?
I can't remember. I'm trying to. It's like too many things going through my head. I'm like,
Distribution.
I guess we can go with that one and see if it's wrong later.
Yeah.
Yeah, because it's just not. Okay, hold on. Under number 3 in the textbook, probability involving a mean, and down under normal curve, after finding a z-score, we can use a normal probability applet to find the area under the curve. Suppose that a sample size of 4 has been drawn from a population with a mean of 7 and a standard deviation of 3. Since the parent population is normal, we know that the sampling distribution of the sample mean will be normal with mean 7 and standard deviation of 3 divided by 4. This probability of z will be greater. Yeah, I'm guessing at this point we're gonna have to guess. Hope that it's the sample mean and we'll figure it out. All right.
Yeah, I'm pretty sure it's that one. I'm not positive, but I'm pretty sure it's that one.
Yeah, and I can't.
Distribution of a sample mean.
Because I haven't gone through the videos and everything yet, I'm not.
I only watched the first one.
I apologize.
Note.
I was going to get ready to go through the one where he goes through all of the preparation problems, because then it really shows me how to do it. But like I said, I had 45 minutes between my 2 group meetings.
Me too. Well, I have an hour.
Yeah. But so that's my fault. Okay. Which of the following results implies that the spread in X or mean decreases as the sample size increases?
A lot of large numbers.
Is that the large number one?
Yeah.
The sample size gets larger, the sample mean will get closer to the population mean.
Correct. So it's the.
Yeah.
Using the following information to answer the next 4 questions.
Okay.
This means I need to know the math, and I'm not positive I know all the math yet. So, all right.
Okay.
Using,
So scores from the quantity portion of the GRE are approximately normally distributed with mean 150.8 and standard deviation of 8.8. Okay. So the question.
So the z-score,
And 160. That's the score, right?
so that's the score she got. So you take that score minus the mean,
Which is 150.8.
0.8, and divide
Yes.
that by the standard deviation.
Which is 8.8.
Yep.
Okay.
Let me get my
So that's what we have to do. And the calculator. Let's see.
So we get 1.0445. 1.045. Is that what you got, Spencer?
Yes, 1.045. Do we have to round it?
That is rounding.
That is rounded.
Round your answer to okay.
What is the probability that a randomly selected student will score above the 160th on the quantitative portion? So opening the applet, it says scores above that.
0.85. Oh, this one.
No. Above 160.
Okay, so then you put the z-score from the last one in at 1.045,
Yep.
and you need above that score.
Which is
0.1480.
80. Yes.
I got 0.148.
Yep.
That's the one that I got. Yes.
Awesome. Okay. A random sample of 5 students was selected to take it. Your score was.
Five students, the scores. What is the z-score corresponding to the sample student score?
So if we pull up our quantitative descriptive
Adi, be quiet, por favor.
number, 160, 175, 163, 149, 153. Right?
800.
So if you call out the sample mean would be the mean of those 5 scores, right?
Mm-hmm.
Okay, if I put it in the Excel
So
sheet, mean says it's 160.
Yeah.
So then the same as the other one, right?
Correct.
Hold on. So we have to add these numbers and divide it by something?
5. You get the
By
mean?
5? Okay.
I just put them in the Excel spreadsheet and had the quantitative descriptive part do it, but we should get the same answer.
Was it the 1.045 or is it the 0.148?
160?
Oh, I see what you're saying. The score is 1.045 because it's
Yeah.
the same math as above.
Correct.
Does that make sense, Patricia?
No, I'm lost.
Okay, so you got the mean by adding them up and dividing, so like the average.
160, yes.
And then we plug that back into the z-score. So 160 minus the 150.8 mean divided by the 8.8.
Yes.
And that comes up with 1.045.
Which is the same as number 6.
Okay.
Or before we put it in, yeah, number 6. That's right, because then they had us do that part.
Yes.
Okay.
I don't explain myself very well. I just do it. I'm like,
No, that's fine. And I apologize. I'm not better prepared tonight. I've got a headache that's turning into a migraine, and it just makes me just not able to think very well. So, okay. Number 9. What's the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Oh, wow.
Okay, so the mean was 160, right?
Yeah, but it's what's the probability? This is where that new formula comes in that we just talked about. So
it is 160 minus 150.8 divided by 8.8 divided by the n, which is 160. Is that right?
I don't think the n is 160. It's 5 because there's 5 randomly selected students.
Okay.
I think too. Yeah.
See, I don't know how to write problems. Anyway.
8, which is divided by the square root of 5. Let me do all that math. Let's see. 8.8.
Okay.
Root is
so it's 9.2 divided
3.935979 equals. I got an answer of 2.337. Is that what you got, Spencer?
no, I'm trying to finish it up right now.
Okay.
Yep, 2.338.
2.337. Let me look at. Maybe I rounded it to
2.3377. 2.338.
Is that what you're getting, Patricia?
I'm still getting it. Let's see. Yep. 2.37. Right?
2.337.
Is that rounded?
Yeah, I'm rounding it. It was 2.3377.
Okay.
I got 2.3374.
377. Right.
You got 77, Patricia?
Yep.
Then we'll round it to 338. I might have just kept a longer decimal at some point. Oops. Okay. The mean of the 3.5. Standard deviation is 0.7. Left skewed. A random sample of 81, which means that it is normally distributed. Okay, look.
Hold on.
What is the shape of the sampling distribution of a random variable x which represents the sample mean of the 81 students?
Who are the left?
It's approximately normal because the sample is larger than 30.
That makes sense.
And that's the rule for everything, that it has to be greater than 30.
Yes. That was yesterday's rule number. It's on today's preparations also.
Oh, yeah. Okay. What is the mean of the distribution sample mean? What is the mean of the distribution sample means?
Is it 3.5?
Yeah.
Because it's the same.
Yes. Yeah. The mean of the mean is the mean. The same as the mean.
The mean of the mean. Where are you getting that from?
That was last week's, at the beginning of the week's last lesson.
Yeah.
Lesson 6.
Okay. It's true. There was like, yeah, too many words. I remember. Okay.
Agreed.
What is the standard deviation of the distribution of the sample means for a possible sample of the class? Drawn from current population. What is the standard deviation of the distribution sample? The mean of, so is O divided by root n. That's the standard deviation of the sample means.
Yep, I think you're right. So then you take, yeah, so the 0.7 divided by the square root of 81.
Mm-hmm.
I agree.
Okay, so 0.7 divided by, hold on, what is the formula? Yeah, the root of 81.
Yep.
0.078.
Yeah, that's what I got.
Okay.
0.0007, yeah, okay, rounded.
0.078. Yep.
Okay, what is the problem?
So 81 randomly selected BYU Idaho students. 0.3 ones for 3 decimals.
What is the probability that the mean GPA?
So you take the mean,
Which is,
isn't it 3.3 minus 3.5? I think it's the z-score to the area. So 3.3 minus 3.5 divided by the
81.
80.
Square root of.
Is it? Yeah. Square root of
0.078. Oh, is that the other? Because we got the 0.078.
Is that it? Is it?
The square root of 81, or is it the point? But the result of that one was 0.078.
yes.
Okay.
So that's divided by.
That's divided by 0.07.
0.78. Yes.
I don't. All of a sudden, I'm questioning myself. So hold on a second.
Okay.
I just need to look at my formula because all of a sudden my brain just like lost the formula.
Yeah, I have to.
3 weeks or whatever, but
Yeah, because Z is equal X minus U divided by O divided by the square root of N. That is the.
well, that's this week's, but I don't think it's going that far yet.
Oh, really?
Yeah.
I
Trying to
think
figure.
I think it's it's just over the O, which is just they already gave us. No, maybe not. Maybe you're right. Because we don't have the standard deviation, because that's what goes on the bottom is the standard deviation. So if we don't have the standard deviation, then that's when I think we plug in the new formula, which is
For the probability. Yeah.
but I don't
know. You made me that dumb.
no, I just don't know. What do we put over the square root of 81? Because I have Z equals 3.3 minus 3.5 divided by, and then what do you guys have next?
That's O divided by the root, square root of N.
Divided by the square root of 81.
So what's O?
0.7.
No.
Oh,
Was it?
you're right. So if we have the standard deviation, then don't we just use the 0.7 and not the square root of 81? Because we have the standard deviation.
Right. Yeah, it is just a 0.7.
Does that make sense, Patricia?
Yeah, it is just a 0.7.
I think because it's like we're using last week's formula. We haven't moved to this week's yet in this question because we already know what the standard deviation is. My guess is the next question they'll change that.
Okay.
But
let's see.
I think
because this one is less than 3.3.
divided by 0.7 equals negative 0.286. Is that what you guys got?
Yep, I agreed.
And then let me get into my applet. And they want less than?
Yeah.
Okay, so the area, which is also considered the probability, 0.37 or 8 around. Oh no, we don't round that one. 7. 0.387.
Yep.
Is that what you got, Patricia?
No, I'm not there yet.
Okay, we'll give you a
That's
second.
the probability once you write down. Hold on. The scores, right? In the probability applet?
You put the z-score in.
Yes, which was 0. No. Okay. 37. And what areas we marked? Below 1, right? Below -1?
Right.
Okay.
Well, below it's below the z-score. So yeah, you just mark the one to the left.
Yes, to the left.
So the area is 0.3874.
Yes. Okay. 0.3874. Yes.
So the next one is the same question, but it wants it greater.
Greater. So it will be the positive side.
So, and it's the same number because they're equal. So it's the same, 0.387.
Mm-hmm.
That makes sense. I agree.
Okay. So,
The United States Coast Guard claims that mean weight of passengers in commercial boats is 185 pounds.
so that's the mean, 180 pounds. Okay. The previous value.
Value was lower but was raised after a tragic boating accident. The standard deviation of a passenger weight is 26. So, that's a light person. But I
Only
guess,
kids can ride.
yeah, I'm thinking, I'm dead. I don't even know what that means. All right. The weight is of a random sampling of 48 commercial boat passengers were recorded. The sample mean was determined to be 177 pounds, 0.6 pounds. Find the probability that a random sample of passengers will have a weight that is extreme or more extreme than was observed in this sample. Okay.
So greater. Okay.
Greater than or less than the mean. So we're just
So I think this is where
we use that formula.
we use that next one.
Do we? Because it still gives you the standard deviation, doesn't it?
Yeah, but then from that, the sample of 48. Let's see here. Let me read it again. Oh, yeah, see?
So it will be sample deviation.
So you're saying it's the one?
Well, I'm thinking the standard deviation is 26.7, but
Yeah.
Yes.
And then N is 48.
Yeah.
correct.
So why would they not have us use the new? Whatever.
I don't. I have no idea.
Now we have to use it. So
177.6 minus 185
exactly. Divided by 26.7 and the square root of 48. Is that right?
I think so.
Let's hope so.
I'm trying to look at. I'm just looking at my notes.
Yeah, I mean, you have to. Let's see.
The population mean. What was the population mean?
177. Oh, the mean was 185.
85.
Yes, but
Let's see. If a sample.
the sample mean, the population mean, that's the 177.6. So that's the population. Okay. Sample means same thing. Okay.
It says the sample mean, then we use the new one under number 3 in the book.
Yeah, it says sample mean.
Yeah.
So did we get the last one wrong? Did the last one say sample mean?
I don't think so.
Let me look again. I don't think it did.
No.
Okay. So let's look at the new formula and hope that works.
Yes.
So we said 177.6 minus 85 divided by 26.7 divided by the square root of 48.
Yes.
Yep.
Okay. Let's do it.
So repeat that one more time. I'm lost. What are we doing?
Okay, so we're going to use the new formula.
Okay.
So 177 minus 6. Sorry.
Minus
177.6
Okay.
minus 185
Okay.
divided by the standard
26.7.
deviation, which is 26.7 divided by the square root of
48.
I think.
Okay.
Chase 26. 7 divided.
Parentheses, enter. And I get an answer of negative 1.920. And that would be the Z score.
I got minus 1.92.
Yes, that's
Okay.
what I got.
92 over 7. Okay. So we'll have
It
to use
wants to know what is the extreme, either above or below the mean. So
So what did you guys get?
negative 1.920.
0.92. 92.
What did
So
you?
we have to put that data in the Z-score, and
Yes,
the probability will be given in the area, right?
right, but I don't know.
There it is. Okay.
Okay,
I figured out what
So-
it was.
It has to be extreme or more extreme. So below and up, the
So
Z-score.
the mean is 180. So the mean's the 0 in the middle of the probability applet, right? So we want what's
Yes.
above or below.
Mm-hmm. Yep,
I don't know if you.
which is 0.054.
Yes. 0.055.
55, we'll round it.
The left and the right highlighted.
Yes. Okay, it has to be that.
Yeah, maybe. Oops, 5.5. We're rounding that.
Yes.
Mm.
It has to be.
Okay.
0.055.
Yes. If you round it, yes.
Yeah. 0.055.
Okay.
Okay, I'll go.
All right.
Wish me luck.
May the force be with you.
Okay. Let's see. Let's see. Okay, we got wrong number 8. It was 1.045. What I wrote.
That's
Let me
what we.
see, number-
So number 8's wrong.
Number
Is that
8,
the only one we missed?
9,
We got wrong. Okay.
13, and 14.
Oh, gee.
Holy smokes.
Nice.
Okay. So
What did we do wrong? Well, at least 15, we got it right. So 8. A random sample of 5 students. Their scores are. Why does this score corresponding to the sample mean of these students' scores?
So I'm wondering if on question 8, it's supposed to be. When we figured out
The random students.
we didn't put the. I think we needed to on that one. I think we needed to use the new formula. Oh no. We did.
No, because it's not asking the probability. What is asking?
Because what does the Z score corresponding to the sample mean?
Yeah, but when they say they did a sample, a random sample of 5 students,
Correct.
and so we know that that's less than
It's less than 30. I don't know. I'm so lost. So, where's the z-score corresponding to the sample mean of these two scores?
Whereas
So
if
what does the sample mean? We need to figure out the sample mean.
you add all the numbers up and you divide by 5. That's the mean
Yes.
of the sample,
Correct.
and that's 160.
Yeah,
Yes.
that's what we got the first time, which we got that. But what do we do now? We got to.
So
What did we do wrong with
is this the
that? Is it
one?
what?
I think this is where we need to plug it into.
Or is the z-score just 160?
No,
Oh, that's right.
that's. I think what it is when you do the 160 minus the 150.8, and then do the new formula. So divided by 8.8 divided by the square root of 5, because there was 5 people.
Okay.
This is a guess.
I don't understand it. Why would
Because
this?
before, when we did these problems at the beginning of the week, we had the whole population. When we were figuring out z-scores, we were figuring them out for the whole population. But in question 8, it says a random sample of 5 students. So instead of having 180 students or having the entire population, we only have 5. So then it changes the standard deviation, if I understand properly. So if I figure the math right, that's 2.
So that would mean the other problem would be the exact same.
Number 9, we got wrong.
Yes. 2.338, right?
Yeah.
Yeah,
So
because that's the way we did that exact one, which would be 160 minus the 150.8 divided by 8.8
yeah,
divided
but
by
I'm
the square
wondering
root
if
of
that
5.
233 needs to go into the z-score, and then we need to find the area with it. Because it's asking for the probability, it's not asking for the z-score on question 9.
Yes.
So if we put the 2.338 and 8, and then let's plug it in to our applet. 2.338, and it wants a score higher, greater than the mean. So if it's greater than the mean, is it just the right-hand side that we click, or is it both? Just the right-hand side, right?
That's the right-hand side.
Then
We
that's,
get 0.0097.
yeah, so 0.01. Does that sound right? Is that what you got?
Sorry.
Yeah.
Okay.
Well, it would be 0.0. Yeah. Because it's rounded, right?
Yeah.
Yeah.
Does that make sense, Patricia? Kind of?
Yeah. I need to process it
We
in my
pretty
head.
much switched what we did. We just didn't. We needed the answer for number 8. It was number 9, and we just didn't
Yes.
solve 9 all the way.
Right. We just figured that that was.
Okay.
Okay.
So the next question we have wrong is 13.
So 13.
Oh.
So the GPA for these students are 3.5. So that's the mean. 3.5.
3.3. Oh, you're saying that, yeah.
Yes. So the standard deviation is 0.7.
I think we have to do the same thing. I think we have to put this one into the applet.
Oh yeah, you're right.
because it's
No,
looking for the probability.
We did put it in the applet. That's what we
Yes,
got.
we did.
Did we put it in the applet?
Yeah, but we did not use the new formula on this one.
Okay.
Do we need to? Maybe we do because it says just for 81 randomly. Did the whole problem have 81 students? Yeah. So I feel like because this is the full one that we didn't need to, but
And it doesn't say sample mean either. It's not.
right. But we figured it out unless the rounding was wrong. Let's do the math again and see if maybe that's just the problem. 3.3 minus 3.5 divided by 0.7. Negative 0.85. 0.28. Yeah, rounding 6. Negative. So let's go back to the applet and put it 6. The question is asking less than. Yeah, I get the same. But you guys, yeah, I get 0.387. Is that what you got on that one? Is that what we
Yeah.
put? 0.387?
0.387.
So what are we doing wrong in the formula?
Unless our numbers are off somewhere. Let's see.
Would the 81 on that one be the N?
Yes. Should we just plug it into the new formula and see if that answer goes?
Oh, yeah.
I don't know what else, I don't even know what else to try.
I think that's the only thing we can do.
So
So one question, why is 3.3 minus 3.5 and not backwards?
because you use the 3.5 is the mean they give you.
Yes.
And 3 is the one in the problem or the X. I'm going to try to do it with the new formula and see what I get. I'll turn it in. A negative 2.57. And we want greater. So the answer I get for area or probability is 0.005.
So that's,
I don't know. I don't know.
and you mark the area below the negative, right?
Less than. Oh no, I didn't. Greater than. Hold on. Let me fix that. It's the same though.
What answer did you get?
I got 0.005. Is that what you got?
The one right before that. The Z-score.
Oh, I got negative 2.57.
Yep. Okay.
Is that what you got?
Yep.
Didn't we get
Then it would be the same.
0.28?
Maybe. All right. I'll try it. So we have 8 is, I'm just going to write down the answers so I know when they're wrong or right. Okay. Save all.
You got 0.0051 for that one then?
Yeah, and then take off the 1.
And that's the same answer. Okay, good luck.
All
What
right.
about 14? What did we put for that one?
It's the opposite, or I mean, it's the same.
It's a greater area.
The first one's less than, and the next one's greater than.
Did we miss any?
Hold on, let's see. We still got 14 wrong.
Gosh, dang it.
So we got 8 and 9 correct?
Yep, we got 8 and 9, and we got 13, meaning we got that right answer.
So how is it possible?
I don't know.
Both numbers are the same, supposedly.
No.
Oh my gosh.
Is it negative?
I didn't think that a probability could be negative.
It can't be. I was just trying to think of something.
How is it possible? I'm lost. Seriously.
I am too.
I
Thinking, what if
understand.
Go ahead.
it's greater than? So it's greater than. So I'm thinking, remember, it's the whole middle piece and the right piece.
Huh.
Oh, you know what?
So
I
if it's
think you're
greater,
right.
Oh my
everything
gosh.
greater than 2.57, so it's 0.9949.
You're right.
Yes, that makes sense.
5. Yeah. Oh.
Yeah.
This should not be this big of a struggle tonight.
I know.
Oh.
Okay.
I'm
Right.
submitting it. That's,
I was going to say someone else's turn.
So
That's got to be it.
all right. So what I actually put them in the wrong spots.
Oh, no.
Yeah. Let's see. So I'm gonna need help on this one. Let's see.
I am too. 'Cause I was
You got all the rest of them right, but I switched 14 and 15. So. What's 15 supposed to be again?
15.
I already turned mine off. I mean, I already pushed redo, which means I lost all of my answers.
0.055. That's 15.
And then 14.
0.055.
Yes.
Okay, and then 14 was the 0.995.
Yeah.
So 13 and 15 are the, so 13 is 0.005.
Yes.
12 is 0.078.
Yes.
11 is 3.5.
Yep.
10 is approximately normal.
Mm-hmm.
9 is 0.01.
No. Yes.
8 is
Okay.
2.338.
Yep.
Okay, 7 is 0.148.
Yes.
Which one is that? What is number 7?
7.148.
7.148?
Nope, 0.148.
48. Okay.
Number 6 is 1.045.
Okay.
Yes.
Number 5 is the law of large numbers,
Mm-hmm.
or the distribution of the sample mean.
Yes.
Number 3.175.
Yes.
What was that?
And the other
0.174?
0.175.
Okay. I will try again. Yep, that's right.
Mm-hmm. Oh my gosh.
Wow.
I know.
Well, that was an interesting
I'm
one.
speechless.
Well, my suggestion is that, at least what I'm going to do is I'm going to watch all those videos probably tomorrow because I have to do something for my religion class tonight. But
Yeah.
so I'll go ahead and
I'm gonna watch them again.
yeah, yeah. Speechless. I don't know. Thank
I mean,
you for muddling through.
Oh, I totally understand. It wasn't.
yeah. I don't know what I'm gonna do. I mean, I have a really hard time understanding what they are asking me and what formula.
Yeah. That's why I'm hoping if I watch the videos, all of them, again, it'll help me. He'll explain that in the videos.
Yeah.
If not, my suggestion too, Patricia, is ask the TA.
Okay.
That's what they're there for.
Mm-hmm.
And she's willing, from what I understand, she's willing to, help with those kind of things. And she can even come to our session and help us if we need to.
Mm-hmm.
So
Yeah. Definitely, I have to do it.
because I think these are the most important chapters this week, and if we don't understand it, I think it's gonna be harder for the rest of the semester.
Mm-hmm. We're only in week 4. My goodness.
Yeah, you can do it.
Halfway through.
Just
Almost
gotta-
halfway through.
Right? Not quite. Oh,
Right on.
All right. Thanks, guys.
thanks. Have a
You're
good evening.
welcome. You too. Take
Night.
care. Bye bye.